break the number. So breaking a number is to see better how it works. So then an example, if I have a number which is 12, you can actually break it down to see how this number works. And then you can find the factors, which means a factor are the numbers that when you multiply, you get another number. So then those are the numbers that when you multiply, they get another number. So then as I said, 2 is one factor, 1 could be another factor, 2 times 1 is 2. So then the factors of 12, I'm gonna break it down. I'm gonna find the half. So 12, I can divide it by 2. I start like that, 2, 3, 4, and I start moving forward. So then 2, if I divide it, it's gonna be 6, yes? And then if I divide it, it's gonna be 3, yes? And then here, I cannot go more because 3, I cannot divide it by 2. I just need to divide it right now by 1. So then it's gonna be 1 times 3 is 3. 3 times 2 is 6. 6 times 2 is 12. So you go like in a zigzag, 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 zigzag. You go tack, 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 tack. And when I'm gonna lay it out, I can lay it out in different ways. I can lay it out in a way of 2 times 2 times 3, or I can start playing with these numbers around. I can group them, and I can create different configurations. So then I can say that the 12 is gonna be 2 times 2 is gonna be 4 times 3, that's one configuration. The other configuration is 2 times 6, 2 and 3. And then remember, I also have the 12 and I also have the 1. Because any number is gonna be divisible by itself and by 1. So then I'm gonna have, what are gonna be the factors? Factors are gonna be 2, are gonna be 3, are gonna be 4, are gonna be 6, gonna be 12 and 1. Yep. 2, 3, 4, 6, 12 and 1. Because I can have different arrays. I can have 2 times 3, 2 times 6, 3 times 4. I can have 12 times 1. So this is a way of laying it out that it helps, is really helpful. So I can know all the factors. So then remember, the 1 is always going to be there by default, and the number by itself. Then you just need to break it down to find the other components. So then I have my 2, then I have my 3, then I have my 4, and then I have my 6. So remember, that is for factors. Now moving forward, we are moving forward with working with numbers. When you're working with numbers, you can actually have numbers expressed in different ways. So then we can have a fraction, we can have a decimal, or we can have a percentage. So then we can have, for example, a number. I can say half, which is a fraction. I can set a number, which is 0.5. If I divide 1 by 2, it's going to be a number. Or on the other hand, actually I can even represent it as 50%, which is half. And that could be something that you find in stores when you said, oh, all our items are 50% off, or all our items are half off. They mean kind of like the same, you know, in a way. So then it's good actually to be aware of these type of things. So then we also have fractions. To remember with fractions how we work, we have a numerator and then we have a denominator. So the numerator is gonna be up, up, up in the sky. That guy is always gonna be there, kind of up. That is always gonna be the numerator. And then denominator. As you can see, guys, my handwriting is not the best. So you have the slides, you have the PowerPoint, so you can actually follow. And then when we're actually using fractions, it's really important to know how these numbers work in a way that b never, or the denominator never can be 0. So it is always a good practice if you can actually simplify, find the integer numbers, so something that is simple. So let's say, for example, if I have 3 and then this is better to express it like this. It is better to work with a whole number. Find easier ways to work. But it also depends how you feel more comfortable. So then that's the other thing, and in my advice, it's just how you feel comfortable. So really quick, we're having fractions. So some rules of fractions. When we're doing addition, super important, super important. We're having addition and subtraction always requires common or equal denominator. They need to have the same denominator, because it's kind of saying is apples with apples, apples with bananas, not really. So we need always to find the best way of doing this. So if I have, for example, two numbers that they already have a common denominator, easy peasy. Why? Because I just do everything straight. I do it straight in a way that numerator talks to numerator, denominator deals with denominator. In a way that I'm gonna add the number on top, which is 1 times 2 is 3. But watch out, this is not 10. This is, we're adding fractions. So then you're gonna keep that 5, okay? So that's also something common that I have 6, which is 3 divided by 5. You can continue or you can carry that number. If you're actually doing a different type of equation, you can even simplify it even later with something that is more laid out, but it depends. Then on the other hand, the same thing with subtractions. Let's say, for example, you have again, I don't know, 7, and then you have 2, yes? So then again, if I have the denominator, I can just go right away. Numerator talks to numerator. 7 minus 2 is 5, and then I'm gonna keep the denominator. Remember, this is the number that I'm keeping there. I'm not subtracting, because this will be 3 minus 3, 0, not really. So then this is a wrong way of solving it. I just need to keep it like this. But we have other options. We have actually other properties for fractions. Rule of multiplication. So then with the multiplication is actually pretty straightforward. Multiplication is in a way that you're gonna just solve it in a way that you are gonna go straightforward. But let's say, for example, you are gonna solve something and then you don't have the same denominator. Yeah? To find better ways of. So I have 1 divided by 2 plus 2 divided by 3. As you can see, denominators are different. I have 2 versus 3. So I cannot just go straight right away, straight to the wall. Not really. Wait, hold on. I need to find a common denominator. What is the number that those two have in common? That's how I can think. What number they share, what they have in common, what they have in common. We are finding common ground, okay? That's what you're doing, finding common ground. So then a way of finding common ground, let me see. So always, if I multiply those two numbers, that's gonna be a easy peasy. So 2 times 3. Sometimes you can find another type of number, but here this is like a really simple example to understand the principle. So then here, since this is a fraction, it has a balance. So then I cannot change, I cannot alter things in life. So whatever I do in the numerator, which is up, I need to do it in the denominator. So then if I need to convert 2, into 6, I'm gonna multiply it by 3. So here I need to multiply times 3, and whatever I do on the bottom, I'm doing it on top. So times 3 times 3, and the same thing is gonna happen on the other hand, on the other side of the equation. That 3 needs to find common ground, and a way of finding common ground is with the 2. So I'm gonna multiply it by 2. So 3 times 2. But then remember, whatever happens on the floor, it happens upstairs. So then it means I also need to multiply upstairs. So then a way of solving this, now I have a common ground. Now we're sharing this place, which is called 6. So then the result, 2 times 3, 3 times 2, that's 6, yes. And here I'm gonna solve really simple. 1 times 3 is 3. And then I'm gonna solve 2 times 2 is 4. And then I'm gonna add, yes, denominator 6, 4 plus 3 is 7. Yep, 7 divided by 6. I need to stop there, okay? Because I cannot continue moving forward. I cannot simplify. But it's also a good rule to simplify. Let's say, for example, you encounter a number, and then let me see a number. Yeah, this is the result. You are solving something, and then you have this number, 48 divided by 16. If you carry that number with all the multiplications, that number is going to be big, 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 big. So you want to make things simple, keep it simple. So how you do it, you divide, you simplify. So let's try to simplify. Easy way is like finding, I can't find the halves of these guys. So if I cut, half of 16 is 8, half of 24 is, or half of 48 is 24. My brain was ahead. Then what else can I do? Can I just continue dividing? Yes, sure you can. So then I can set 24, which is 8, 3. 24 divided by 8 is 3. Can actually do it right there. That will be 1. Or I can do it even in half. Let's say, for example, I didn't notice this. I can continue doing it like this. Yes? I can set half, 12, half, 4. Yeah? But let's say, for example, I still can continue. Yes? I realize, oh, wait, I still can continue. There we go. So then half, 6, half, 2. Huh? Yeah, yo. And then I have 6, and then I have 2. Can I do a half? Can I divide it? Yes. 6 divided by 2 is equal to, guess what? 3. So then this is the beauty of math. It will get you places. It will get you to answers. Something that is straightforward. Something that is more objective. So then that's with simplification. So with the simplification is good. It's a good practice. So things can be easier. And then moving forward, yeah, yo. So we can find reciprocals and then divisors. So then the reciprocal is when it's a number that is multiplied by itself, and then the result is always going to be 1. So then a way of doing it is inverting it. So then you have your slides, you have your PowerPoint. So let's say, for example, I'm finding the reciprocal of 2. So I need a number that when I'm going to multiply, it's going to be 1. It's pretty simple. And a way is reversing it. You just reverse it. Reverse it in a way that I'm just gonna cancel these two guys, and then it's gonna be 1. So then the reciprocal of A, it will be 1 divided by A, or the reciprocal of A, B, it will be B divided by A. Yes, for the same reason. If I multiply, I just start canceling, and then it's gonna be 1. So then if I have A, B times B, A is gone, B is gone. That's not 0, that's 1. Remember, we're simplifying, okay? So then that's the reciprocal. And then connected with the reciprocal, we're gonna do I think our next also topic is divisions and multiplication, which I mentioned it before. So this is something gonna be that straightforward. Say for example, I have this fraction. And the way it works with multiplication is that you're just gonna do numerator with numerator, denominator with denominator. It's like they're partners, they're a couple. So then the numerators are always together. They can go, they don't need any permission, so they can do it right away. Same thing with the denominator. So then I'm just gonna do things straight away. I don't need to find common denominators. I don't need to like if I can simplify, that will be a good one. So then the number doesn't get that big. But you just do it straight. You just do it right away. 1 times 4 is 4, and then 3 times 2 is 6. Perfect. Can you simplify? Yes. La mitad de 4, 2, half, 3. Yes? Moving forward. Divisions. So now that we know how the multiplication works, so then we also have the topic of divisions. So then divisions are really beautiful. And you can solve it in 2 ways. Let's say, for example, you have 10 divided by 1.5. Yes? You can solve it in 2 ways. The first approach, again, this depends how you feel more comfortable. You're gonna multiply by the reciprocal. And then remember, we learn. So we have 1 divided by 2. Which one is the reciprocal? So then the reciprocal is gonna be the number inverted. So the numerator moves into the up floor, and then the denominator, they're gonna switch apartments. Yeah, I'm switching an apartment. When I'm a reciprocal, we switching. And what I'm gonna do, I'm gonna multiply with the reciprocal. What is the reciprocal of 1.5? 2. Yes? So then what is the answer of 10 divided by 1.5? It will be 20. Great. However, that's not the only approach. There is another rule, and I learned this rule a long time ago when I was studying, and we call it la regla de la oreja, which is the ear rule, which means you're gonna take the number, which is 10 divided by 1.5, yes, and I'm gonna divide it. So I'm gonna divide it, yes, divided by what? So 10 divided by 1.5. But this 10, in order to do the ear rule, I need to add a number. And then remember, 10 is equal to 10 divided by 1. That's exactly the same. 10 divided by 1 is 10. Yeah? Those are equal. So I can just keep it like this. So I'm not altering this number. Yes? So now that I have this, I'm gonna look my earring. And since I'm gonna do my earring, I wanna do it with a different color. And my earring, yayo, is all the extremes. 10. 10 times 2, and then 1 times 1. 10 times 2 is equal to 20, and then 1 times 1 is equal to 1. Yeah? Which is, in a way, 20. You see, we have the same result. So then again, this is how you feel. So then this is gonna be with the external. The most external goes and you're doing like an earring. Did you see that? You're just having here, you just pierce here, and then put some cute earrings. Yep. So 10, which is the external, goes with the outer, which is the denominator. So then it will be numerator times denominator, goes on top. Denominator times numerator. They're gonna be like, which in a way, that's the same thing that you're doing here. You're flipping. You're flipping. You just need to be conscious about who is gonna stay in the up floor and who is in the lower floor, or numerator, denominator. So things to consider when you're solving problems, you're gonna consider about paired, hyperfed, square, cube, or qubit. It's really important to think about units. Units are really important. Keep always in mind, units are a key component to let you know if you're in the right track. Because when you're canceling something that you shouldn't, you should actually go back and revisit. So that's what is so important. The first method that I show, which is the regla de tres, which is kind of like the visual. You're gonna multiply with the diagonal and then you're gonna divide. That is not always as effective, and I'm gonna explain why. When you're laying out multiple equations and you need to solve something, if you don't have the clarity of your units, sometimes you can get confused and that could be a problem. So then that's what it sometimes is, even laying out the equations in a way that you keep it. Where is the location of the unit? Is the unit gonna be on the numerator, denominator? If I cancel, it makes sense, or if I cancel, it doesn't make sense. So then that's the type of things that you need to know before you're using any method. Finally, something really important is to practice. You always need to practice, read the material. If you have any questions, let me know. This material and this class is always designed for you to have tools, but I want you, of course, to feel comfortable. Feel comfortable and do not feel stressed. Do not feel stressed about solving problems. Here, you have tools, you have ways, you can actually use your calculator, you can research things online. Right now, my God, there are so many great videos, there are so many resources out there that you can tap. So then remember, and at the end, it's not about just doing an equation or solving something, it's about giving the meaning. And then that is what is more important. It's about understanding the numbers and what it means. Because in the real world, those numbers are the ones that are gonna make your business succeed or close down, change gears, and then readapt to something completely different. So then that's it. Thank you so much. Remember again, I'm here for you. If you have any questions, you can ask your peers, you can ask me, you can check the Idea Center, and then see you next time. Bye.